All right, section 5.7, essential question, how do you find all the zeros in a function? Okay, on the last section we found the all the real zeros. Now we're going to find all the zeros, like irrational zeros. Well, we found all rational zeros last section. We're going to find all the irrational zeros and complex zeros, and also talk about multiplicity of zeros. Fundamental theorem of algebra basically states that what all that means, I know that's kind of complex, but basically means whatever your biggest exponent is, that's how many solutions you should have. Okay, now some of those solutions might be like the same solution multiplicity, and we'll talk about that. Some of those solutions might be imaginary, some of those solutions may be irrational, like square roots, but you should have that many solutions as the exponent. So like on example 1, it says how many solutions does the equation have? It would just be 3, because the biggest exponent is 3. Okay. How many zeros does the function have? Solution zeros, it means the same thing. This would be 4 because the biggest exponent is 4. Okay, pretty easy. Not too much to that. Okay, we're going to move on. So it says find all the zeros of the function. Now, this particular problem, there's a bunch of different ways you can solve, but this particular problem, if you can recognize it, can be factored by grouping. So that's the way I'm going to do it. Okay. So first thing I'm going to do is set equals 0. Okay, and then I know that if there's 4 of them, and I can factor. If I can factor by grouping, I'm going to do that. So I'm going to group the first 2, group the last 2, and I can take out x squared and be left with x plus 1, and I can take out a positive 4 and be left with x plus 1. Okay. So then I can rewrite it as x squared plus 4 and x plus 1 equals 0. Now, x squared plus 4, if there's x squared minus 4, I'd be able to factor, but x squared plus 4 I cannot. So then I'm just going to set equals 0 and solve. So let's do that over here. X squared plus 4 equals 0. Subtract 4. Get x squared equals negative 4. And you take the square root. And you got to make sure you put your plus or minus. So plus or minus, remember the square root of 4 is 2, but you took the square root of a negative, and every time you take the square root of a negative, you got to have an I. Okay, so plus or minus 2i would be the answer to that. Okay, plus your other answer, which is what makes x plus 1 go to 0, would be negative 1. Okay, so if you wanted to write it out, you can leave it like that, or you can write it as x equals 2i, negative 2i, and negative 1 as your answers. Okay, notice how we have 1, 2, 3 answers, and our biggest exponent was 3. Okay, so you should always have as many answers as the exponent. Okay, that one you could have solved other ways, but that was probably the way I would choose to solve it. Okay, this next one, okay, says find all the zeros of the function. Okay, so this one, you notice if you try and factor by grouping, you can't do it. It doesn't work out. Okay, so we can't factor by grouping. All right, but maybe you want to make a list like we did in 5.6. List all your zeros. Okay, so we want factors of 9. So plus or minus 1, plus or minus 3, plus or minus 9. Okay. And at this point, you could guess or check those, or you can put it in your graphing calculator. I'll allow that. So let's put it in the graphing calculator. I remember what I just had up there was an x cubed. All the rest of it. Plus 7x squared plus 15x. And then what was the rest of it? Plus 9. Alright, so when we graph that, alright, we get where it crosses, where it looks like it crosses, which would be negative 3 and negative 1. Now, we're supposed to have 3 answers and we only have 2. But something kind of strange happens at negative 3, how it goes up and bounces and hits negative 3, but then it goes back down. We'll talk about that a little bit more. But now we just need to pick one of those, either negative 3 or negative 1, to plug in for synthetic division to break down the problem. Okay, I'm going to pick negative 1, but you could have picked the other one. You could have picked negative divided by 2. So break it down using synthetic division. Bring down to 1, -1, 6, -6, 9, -9, 0. Okay. So then we have to rewrite it in factor form. That would be x plus 1 and x squared plus 6x plus 9 equals 0. Okay. So then what we need to do is factor x squared plus 6x plus 9. You know, factors of 9, add up to 6 and 3 and 3. Okay. Or you could just realize that it's a perfect square trinomial and write it that way, either way. So you can write it as x plus 1, x plus 3, and x plus 3 equals 0. So our three answers are, well, technically it's two answers. It's x equals -1 and -3. But what you would say about -3 is -3 would have a multiplicity I spelled that right, multiplicity of 2, okay? Because there's two answers that have -3 on it. So whenever you have an answer that's double, then you have to write a multiplicity of that. If there's x plus 3 times, we say multiplicity of 3, okay? But, and that takes care of, so -3 has two answers, and -1 has one answer, and that's why you have three answers on that. Which, remember, at the beginning of the problem, we had x to the power of 3, so we should have three answers, okay? You can also notice by the graph, okay, whenever the graph touches a 0 and then bounces and then goes the other direction, it should have a multiplicity of 2. There's also rules for multiplicity of 3 where it bounces, but then it keeps going the other direction. And we'll talk about those maybe when we see one. Okay, but just something to recognize on the graph, how to recognize that. Okay. Complex conjugate theorem. Sometimes what they'll do is they'll give us the zeros, and then they will want us to rewrite it back into a function. Okay, so the complex conjugate theorem says that there's a plus bi 0, then it has to be an a minus bi 0. So you have to do both. Same with irrational conjugate theorem. If there's an a plus square root of b, it has to be an a minus square root of b. You have to add that in. So we'll talk about that. So it says, write a cubic polynomial function that has irrational coefficients, a leading coefficient of 1, and 2 and 2.5, 2 plus square root of 5 or 0. So how we write that is, we want to write it in factor form. 2, if we wrote it in factor form, 2 is a 0, then in factor form that would be x minus 2, because 2 is what makes that go to 0. Okay? And then if we wrote 2 plus square root of 5 in factor form, it would be x plus 2 plus square root of 5. Okay? But you can kind of, keep that in parentheses or whatever, because x plus all of that. All right, but then since it has to be a conjugate, you have to also multiply by, they said every irrational one have a conjugate, so you also have to do x plus 2 minus square root of 5. Okay. So then from there, what we have to do is all right, check that, made a mistake. That would be x minus, because we always do minus if it's positive. So x minus 2 plus radical 5. And then we'd have to do x minus 2, and you got to do the conjugate, which would be minus square root of 5. Okay. So then what we want to do is rewrite it, okay, or regroup it. So we're going to rewrite it as x minus 2 times x minus 2 plus square root of 5. I guess I see use brackets for that. Okay. And then rewrite this one as x minus 2 minus square root of 5. Okay. Because when we multiply that, then we have the difference of two squares. Okay. We got x minus 2 is different, but we have plus square root of 5 and minus square root of 5, okay? What that allows us to do is not have to multiply everything, so we can just multiply. Whenever we have difference of two squares, we can just do the first, which x minus 2 times x minus 2 would be x minus 2 squared, okay? And square root of 5 times negative square root of 5 would be negative square root of 25 would just be negative 5. We could bring down our x minus 2. The reason we don't have to multiply the middle terms is because, remember, if we multiply the middle terms, you know, these two middle terms will cancel out. We don't even need to worry about those, okay? Because whenever you have a difference of two squares, the middle terms always cancel out, and you end up with 2. So then what you want to do is expand x minus 2 squared. So you can do, let's bring down x minus 2. We'd have x minus 2 times x minus 2 minus 5, okay? So that would be, before that, we get x minus 2 times, that would be x squared, negative 2x would be negative 4x plus 4 minus 5, okay? Then you could, check that. That should be included in that. Sorry about that. That should be included in that part right there. Okay, so then we can combine like terms with the x minus 2. So it'd be x minus 2, and then x squared minus 4x, 4 minus 5, and negative 1. Then the last step, just distribute. Okay, and you'd have x cubed, negative 4x squared, negative x, negative 2x squared, 8x, and positive 2. And the last thing I do is just combine like terms. So your answer would be x cubed minus 6x squared plus 7x plus 2. And that would be your answer, okay? Or I guess f of x equals that. Okay, so that's a little confusing. We'll have to talk about that in class, how to do that. Especially with the radicals, it makes it a lot more difficult. Just setting that up and grouping that differently. And we should have kept the x minus 2 separate from that. But we'll talk about that more in class. Okay. All right, this one, write a cubic polynomial function that has rational coefficients linked coefficient 1 and 3 and 4.i and 4i 0. So we have x minus 3 where the 3 is 0, and then we have x minus 4i, but then we'd have to do the conjugate, which would be x plus 4i. Okay, so then again, you want to start with these are, you know, difference of two squares. So we can take shortcuts, just multiply the first two and get x squared, then multiply the last two and get negative, that'd be negative 16i squared, which would turn into positive 16 because I squared equals negative 1. So if we did negative 1 times 16, negative 16, we get positive 16. So that would be x squared plus 16. Okay? So then we can just distribute, or, you know, for them. So you'd have x cubed, that'd be 16x. I'm going to write it in order. So negative 3 times x squared would be negative 3x squared plus 16x minus 48 would be our answer. Okay? And yeah, write a f of x with it. Okay? Okay, so if we follow those, that's how it should be written in standard form. And that would be our answer or not. Okay, so use a graphing calculator to approximate the real zeros. We can bring up a graphing calculator and put it in. I already did that earlier. All right, so let me see which this one is. Give me a second. Okay, so it's x to the power of 6 minus 2x to the power of 5 plus 3x to the power of 4. And I'm doing that all wrong. So I can look up. Okay. 6 minus 2x to the power of 5 squared minus 8x minus 8. I put it in yellow. Okay. So it says it wants us to approximate the zeros. Okay. We can use the zero root function. Remember the zero root function? We just hit second calc. Okay, we go to 0. And we want the cursor to be left of this 0. Doesn't matter how much, hit enter. Then we want the cursor to be right of the 0, hit enter. Then we go to the 0, hit enter. So one of our zeros would be negative 0.73. And then we can do it on the other one. So second 0, or second calc, 0. We want it to be left of it. Doesn't matter how much left of it. Okay. All right, so that's left of it, hit enter, and then we go right of it. That would be right of it. We go to as close as we can, enter. And I know it's hard to see, but the other 0 would be 2.73. You can ignore the 1.2 e to the negative 11 because that just means 0. Okay, that's like 0.00001.2. Okay, so those would be your two zeros you'd write on that. And that's how you would use graphic calculator to approximate real zeros. All right, so there's no problem on that. If you have questions, come back to class. I know you're going to probably have questions on the problems with the where they give you the real zeros and you got to write a function. Okay, and we'll talk about that in class. That is it.